What is going on, Hot Take Nation? It is David Ramstonwood here for another episode of the Hot Take of the Day podcast. And today's guest I'm really excited about, not only because he's a brand new coworker of mine, although this is not a Hitachi podcast, this is not an advertisement. This is because Shamik Mehta and I had a conversation last week about data. And I have to tell you, I thought I understood data or data, depending. I didn't even know how to say the word, if we're being honest. But I thought I knew about data and systems and architecture and integration and everything that's going on in the world as we move from on-premises storage and legacy systems to cloud and AWS and Microsoft and Google. And instead of me trying to even explain it, I thought listeners would really benefit from our conversation. So that is what we're doing. And I want to welcome Shamik to the show. Shamik, how are you doing today?
I am well. Look at that. Our heat wave is winding down. It's in the low 80s today. It's going to be high 70s tomorrow. It's perfect.
I love it. And did you do anything exciting for Father's Day? We are recording this on the Monday, January 21st, so it'll come out in the next week or so. Father's Day, what was it like?
Well, it was, as usual, it was a good Father's Day. I got a ton of attention. I got a free breakfast out of it. And then to celebrate, I went out and took a couple of friends on a bike ride up on Route 9 here behind my house. Rode my bicycle up 2,200 feet and back again, hit a top speed of 37 miles per hour and stayed on the bike. And I'm happy to be alive. So I'm glad to be here today.
I love it. I love it. Well, I did a post yesterday on LinkedIn talking about fathers and sons and the learnings, and it was interesting. I didn't think we would end up there, but I love the U.S. Open. It's my favorite. It's my favorite tournament, probably other than the Masters, but and other than playoff hockey. But I love that it always ends on Father's Day. There was a great win for John Rahm, but just talking about the relationship of fathers and sons and what you learn and all the good and all the bad and Tiger and Earl. So it was a beautiful day. There was fist pumping. John Rahm took down the trophy and it was great. So Shamik, why I had you on, as you know, is so you're with Hitachi Vantara. Why don't you tell people a little bit about what Hitachi Vantara is? People are probably familiar with the Hitachi name, but not so much the Vantara. And then what your role with the company is before we kick off. Let's talk all things data.
Absolutely. All things data. Well, as you already know my name, you pronounce it perfectly, so that's great. I am a director of industry solutions marketing. So I market all of Hitachi Vantara's products, which go all the way from the data center to IT modernization and app modernization, data modernization, all the digital modernization stuff, everything that you heard about, cloud computing and everything. The Internet of Things, industrial Internet of Things, and I market those solutions to our customers in industries such as energy, transportation, manufacturing, healthcare, and others.
So I have to tell you that one of the terms that I was the least familiar with coming into this was IoT, which is, for most people, they know it's Internet of Things. And it was sort of a nebulous concept that it was like every device can be connected to every other device and everything is smart and integrated. Can you do a better description of that and why companies want to go to this IoT platform, framework, system integration? What does that look like?
It's all about just being in the know about what not only the people and your systems are telling you, but also what every device is telling you. Because as battery power shrink, as processors get cheaper, and as connectivity solutions, like with a SIM card or Wi-Fi or mesh networks, whatever, as that all of that gets ubiquitous, it gets cheaper and cheaper. And when it gets so cheap that it's an afterthought, it's not even an afterthought to add that kind of connected functionality to your traditional devices, be it your washing machine or your refrigerator or your microwave or your doorbell or your smart lock or your garage door opener, whatever, to the internet, it becomes an easy thing to do. Because all of a sudden they have a processor inside and a connectivity issue, and now they can communicate. So your doorbell can look out for you and tell you who's at the door. So before they ring the doorbell, you can get an app, that kind of thing. So just a connected ecosystem of all kinds of things.
So, and I get that. So everything's connected to a fault. And I think everyone's had this experience where you're talking about something in your phone. The next time you open it up, it has an ad for whatever it was that you were talking about. So we know that there's more listening and more integration. But I always think about the movie, and perhaps you haven't seen this movie, but the movie's called Pop Star, Never Stop, Never Stoppin'. And it's an Adam Sandberg or Andy Samberg movie. And they decided they were going to roll out this album through refrigerators. And every internet connected fridge at the same time in the country was going to blare their album. And it had epic bad consequences, as you can imagine, because it is a parody and a very, very funny one. But I mean, is there too much connectivity? I mean, I sometimes find I'm on my phone too much. The news is inundating me. I can open things, close things, watch things. I know where my kids are. Where's the trade-off here? And is there a place we go too far? What do you think?
That's a great question. Yes, there is something as too much of everything. And I think the bottom line is it enriching either a business person purpose or somebody's life, including your own? If it is just acting as just one more distraction and not really adding any business benefit to it or some kind of a personal or social, economical or equitable benefit to it, then it's questionable. So yes, there is too much. There is something I like too much with. The way around this would be if the devices start getting smarter on their own without having to first connect to the cloud, to then figure out whether what information I've collected, is it worthwhile for me to share or alert you on your mobile phone. For example, you have a Nest camera outside in your front, looking out in the front yard. It's connected to your smart doorbell or your smart lock. I don't want a notification from a Nest camera to tell me that my son is coming home from school. I want the camera to be smart enough to figure out who that person is and maybe unlock the door for him, or not just alert me about it when I'm at work, right? But that is the camera itself getting smart enough. It's not there yet, but I don't want that notification. I want it to figure it out. And that's what we call edge intelligence, or intelligence at the edge. When the end devices get so smart that it can take basic decisions on its own, such as recognizing who's coming up to the door and not alerting you about it, because it's the same time and the same person that's coming to the door all the time.
So it's fascinating to think about the rate of change of technology. And before we started this podcast, and I've been thinking a lot about it going back to the beginning of my career, there was like one email address for our department when I started. And my job as an intern, not a lot of people know unless you worked with me back there, but my job, I was hired for a 16-month internship. And I was told that my job was going to be taking the field report that was coming in this thing called Excel. And then I had to take it from Excel and rewrite it in the production database called Hoops. And I had followed a long line of interns who had done this job over and over for the previous number of years. And it dawned on me, even though I knew nothing about computers, that there must be a way to automate this exact motion. So I learned how to write VBA. I wrote a macro, and it took all of the things that came in and pasted them in the database. So it came in at 8, and by 8:05, I could run this thing and it was done. And like I had basically finished my job for the day. And that's when I went to my boss. I'm like, I need more stuff to do. And I think back to that, and now I think about how connected, and I feel like Vince Vaughn and Owen Wilson in that movie, The Intern, or The Internship, where they worked at Google, and it's like, it's on the line, it's on the cloud, it's in the cloud, it's on the edge. Talk to me about all these terms. And like, you know, the cloud to me is where Apple wants me to store all my things, that I don't want it to have any of my things. So I have all my cloud devices off. I have find my phone off. But walk me through each of these pieces, and then we're going to talk about data and the cloud and et cetera.
Sure. So it's really quite simple. It's a trio of three things. Any kind of a compute process requires three things. You need to compute it using something called a processor. So you heard about the Intel and the AMD processors, or even some specific processors for gaming applications like an NVIDIA processor. But you need processors to run an algorithm, do some math, do some common functions. Simple things like, changing the column headers on your Excel file takes a processor. Then you need to store memory. So you need data, both to run the process, but also you also need data, like a place to store your Excel files, for example, in the internship example you were talking about. So you need processing power, you need storage, and finally, that duo has to be connected to the outside world. So you're networking. That's what the third thing you need. So you need computing, you need storage, and you need networking. Those three things together, compute, storage, and network, is often combined together into what is a modern day computer, right? One without the other is not likely to run or not going to be very useful. And cloud is simply that same computer, but scale for massive usage, simultaneous usage. So you can have a lot of data, you can have lots of users, and you can have a lot of processing power. Let's say you're running a website of your own and you have maybe 5 customers, and it's to help you book, help them find the best seats for the US Open, right? You have a deal, you have some seats that you reserve and you want to sell them at an auction, whatever that happens to be. If you have 5 to 10 customers, you can run that website out of your own MacBook or your own little laptop that you have, right? Now imagine that that same business is like a Ticketmaster, and you have events that you're trying to sell to millions of customers all around the world, in venues that are in the tens of thousands in every city in the world. And you have multiple different scopes and price ranges and credit card information and lots of customer data to maintain, secure, and everything else. Well, how do you do that? You're not going to be able to run one laptop or one computer to do it. So you need a giant rack of compute and storage and networking abilities, something like a giant IT center rack, as they call it. You may have seen them. They're in a data center. They look like a refrigerator on steroids with all the fancy lights and cabling and everything else going in and out, right? As you add more of those, you can handle more users, you can handle more compute power. You put all these machines together, rack them up, cool them down, custom wiring and everything else, and put them inside a building that's nicely air conditioned. You have a data center. That's basically where a large amounts of this computing is going to be processing.
So
you've heard about cloud computing people like AWS and those people, all they are doing is they're collecting and have invested a lot in this data center technology, not only for their own business, which is how they started off with, but also to rent it out to other people so that smaller businesses like your website, you don't have to rely on managing all of those processor and all the software and all the security and all the IT headache that you may otherwise have to do on your own. You can outsource the whole thing to them.
And that was what I was going to say, because it's interesting when you think about how simple this is, and the conventional thinking would have been network means all the computers connected. But from my own personal standpoint, as I thought about the cloud, one of the things, so my computer recently crashed and I was so concerned I was going to lose all my data because I don't do a very good job of backing it up. So then I think about these mass commercial places where you back it up, but our expectation is, boy, that better be reliable and I better be able to rely on them to do it. And then the second piece on the same token is I recently, and this is the worst, everyone knows, I dropped my phone. And so now we have all the cracking and now the battery won't charge. And so I know I'm going to have to replace this thing, but the changing of the phones is also the worst experience. But since we've gone to the cloud, it's so easy to up and down, and it's really taken things away from the device and made it more centralized than ever before.
Right.
Now, again, what are the downsides of all this centralization when you hear about cybersecurity and hacking and reliability? You know, we're moving to more wind and solar, and that inherently is inherent or intermittent. But we need the data center to be there 100% uptime all the time, which means you have to have backup. So how did all those things interplay?
Anytime you have data not in your own control, you can say that it's vulnerable to getting lost or misused. That can happen. Most of that vulnerability happens when it's in flight. So when the data is moving, either from your device to the cloud or out of the cloud and coming back into your device or something like that. That's where somebody can interpret it. Now, it's not easy to do this anymore. And the more high-profile hacks that you hear about, the technology gets that much better. And so it's not that easy to crack into it. You need to be a very serious nerd to be able to crack into an AWS data center or an Akamai data center to try and get that information. But once in a while, it does happen. And when that happens, a lot of information that you may have, including your social security number, your credit card information, and all of that can get into the wrong hands. So that is the risk that is inherent in outsourcing a lot of your data to any one location. Nobody's vulnerable from that completely. However, data privacy protection and governance tools have come to the point where it's very easy to control who gets to see what data based on their role and their credentials. And a lot of personally identifiable information, the industry calls it PII, personally identifiable information, is often stripped away, even within the same group, in one department, in one company. You and I both work for the same employer. The kind of data that I may have access to or you may have access to is not the same. So even though we are both at the same rank and at the same company, what you have access to and what I have access to is often highly controlled. And it's not done manually. There is no one single IT manager doing it. But governance rules are applied so that only the right application that touch of people, not just people, the people and the application and the program that needs the data is tightly controlled. And that technology is getting better and better. So once you opt in to have that data managed, it will be protected. And I have actually more faith in the cloud handling my data correctly than on my own device. I can lose my device and it can fall into somebody's hands and they can get more information out of it than if it were already backed up in the cloud and the device was completely protected.
I mean, that's a really, I mean, again, that's the evolution where it's now safer elsewhere than it is on our own device. Now, the last story I wanted to talk about before we dive into, and there's a little 2-slide sort of walkthrough that I just thought was brilliant in terms of data. But you told me the story that Amazon, AWS, started because Amazon needed so much web space, and as you described, so many users, so much protection. You know, everyone needed all this, and you used a great example on metadata. I'd love for you to tell people about the birth of AWS, why it was the first really to cloud, and how they've transitioned their business model that's allowing other companies to use their expertise and offload a lot of this. You know, do you want to be a data storage company or a data cloud storage? No, I want to be an oil and gas company or an industrial company or whatever.
Great natural evolution in AWS's case. They built this business of selling books online and then all kinds of products online to customers, right? And the whole philosophy was the more the more products I have and the better my service and how fast I can get that product to a customer means I will attract more sellers. The more sellers and more shops I have means more products I have. That means I have a bigger marketplace and more choice for the customer. That attracts more customers. So all of this continues to scale in a positive cycle. So more customers, more variety, more sellers, lower prices, more customers, more sellers, lower prices, faster delivery. So you can imagine that the infrastructure that they would need, like the example I gave you about your US Open website where you wanted to sell some seats. Now think about the complexity when you have something like this. You have hundreds of countries, you have thousands of cities, you have data that you need to deliver in real time, and it all has to be the same. So the same product information with the same image and the descriptor of what's available and how soon it will ship based upon whether the customer is a Prime member or not. And depending upon who the seller is and what the seller's ratings are, all of this information, including the actual transaction that needs to happen once you say buy now or buy it now or add to your cart, all the transactions that need to happen, it has to happen within seconds, microseconds, nanoseconds, anywhere in the world. The complexity that is involved to create that, Amazon invested a lot in it to create that. And when they were done, they realized that this is something that they can offer to other people as a service, including their own competition if it needed to. But because they had already built out this infrastructure for commerce on an unprecedented scale below, they were able to offer those same cloud computing basics that I just told you about, compute, storage, and networking in many different places, and extremely reliable, 99.49% reliable. That is available, and that availability and scale was then rented out to other customers as cloud computing sources. Doesn't matter what you call it. The fact is that they can do this, or many of these people can do this very, very well, and they can do it better without me having to invest in the right IT knowledge or the hardware knowledge or knowing what server I need and what kind of a DNS I can get, an IP address. I don't want to deal with it. It can be done very well by some of the other folks, right? So AWS started off that way, and now they are a cloud computing giant, as everybody else knows. But it started off in that process.
And then that brought really Google and Microsoft. Is it fair to say that those are the three that would be the big three, and there's maybe some ancillary. And the other thing that I found really interesting in this process is to learn about the partners. And so I'll use AWS just because we're talking about it, but the AWS Partner Network, in terms of Amazon has a skill set, companies like Hitachi Vantara have a skill set. And so for them to combine, it's a very interesting business model that's so much different than some of the old bricks and mortar, where,
Right.
as you said, competitors are competing, but then they're co-branding and co-locating and sharing resources.
Right.
What do you make of that transition and the partner network and how that benefits other companies?
We call ourselves co-opetitors. There are things that we do that they also do, but there are something that we do that they do not, and there's something that they do that we do not. But there's common ground, and a lot of our applications today run on AWS. They're also running on other cloud providers as well, because they already have customers in their space, because they have customers who are also our customers, and there's overlap in products and services that we can offer. Instead of trying to confuse the customer, AWS is a very nice thing by calling something a partner network, and where they may not have a certain skill set, or because they have their customer using a product or a solution that is well understood by their co-opetitor, they partner with them. So we have several examples of our solutions, our IoT solutions for industries where heavy industry, like energy and utilities or manufacturing of large machine parts or whatever. That's not what AWS does, right? So, but by partnering with someone like us, we can bring that value and still keep it on the AWS cloud and provide one unified angle and face to the customer, a common customer.
And so in a retail construct, would I be thinking about it in the same way that app developers are to Apple what perhaps some of these Amazon partners are to AWS, in terms of,
Yes.
that sometimes Apple develops it, but mostly they're relying on external, they have external music, external books, and the Apple framework, the App Store, has sort of integrated everything. And so each are doing the thing they're best at. Is that a fair description?
That is fair. That is fair. That's very correct. There will always be specific niches of expertise required, even at AWS or Microsoft or Google, that they will not have. And they can't go out and become an expert on everything. They're close, but they're not. That's not exactly how things work all the time. And that's not what they want either. The best thing to do there would be to find the community of very smart people and very driven people with well-tested products, integrate them on the back end, make sure that it's working, go through an extensive technical checklist and a business checklist to understand that what they are providing on the network to their common customer or to an end customer not even seen by the application provider is going to stand the test of time, be of high quality, and perform the service it's supposed to. After they have done that rigorous checklist, and I've done this before with AWS and others, it's not easy to get on the partner network because there's a lot of vetting involved. Same thing for an app developer who wants to get something on the Apple iStore, Apple iTunes iStore. You do have to go through several processes to get that thing certified. And only after you've done that can you get exposure to that outside world. It's a partnership model that continues to exist. It'll always exist. No one company is going to own the domain of everything from game creation to selling sticker packs. That's not the forte for Apple. They'd rather have a sticker pack creator who can sell their products through the Apple App Store. So yeah, it's a co-opetition model that's always going to exist.
So this pivots us, I think, really well to data, because the last example that you gave me, and it was so memorable, was the concepts around, like, when I bought an album when I was a kid, right? I remember it wasn't even vinyl. It was like the cassette. You had to fast forward and rewind, and there was the album cover, and you could kind of copy it onto something else, but you had no archiving. And when you compare that to the Apple Store now, where every song, the metadata that is connected with it and the amount of storage and the cross-referencing, talk to me about that, and then maybe bring up that slide deck that you have.
Yeah, it's best anchored.
Data.
Okay, let me anchor that with that slide, because I think that works really well for this. So let me know when you can see this.
I can see it.
All right, so it's really everything that every modern business wants to do is understand the data that they have, because they know that they're sitting on mountains and mountains of data. But how do you find out what insights are contained inside that data? There's likely going to be insights in the data, but you need to study it. So it's all about getting to those insights from the data as fast as you can. and as securely and as reliably and repeatably as you can. Because as I'll explain here, that is 80 to 90% of the work is just preparing the data before you can use it to try to get insights from it. So as this slide shows here on the left, you can have sources from thermometers and cameras and other sensors. So you have things sending data. And at the bottom, you have your databases and your files and your enterprise data warehouses and your data marts and others that are sending their data. The latters are more business data sources, and the former are more IoT data sources.
That's what I was going to ask. Was the upper part would be the IoT, all the devices collecting the data, and then
Correct.
the business sources are sort of where you save it. And I've seen a stat. Can you confirm this? That of the data companies collect, generally speaking, only 1% of the data is analyzed, and the other 99% goes unanalyzed. Is that a true number?
That is a true number. And also, the data is being generated so fast that 90% of the world's data was generated in the last 2 years today. And that number is going to change again in 2 years.
90% of the data that's out there was created in the last 2 years.
Correct. And in the year 2023, 90% of the data in year 2023 would have been created starting this year.
It's incredible.
Yes, and it's growing so fast that it's impossible to keep up with it. So there is no way to take all your sensor data, the IoT data sent by things, and data collected through processes and traditional databases and data sources. It's not possible for human beings to keep up with this deluge, right? But the data is important. Not all of it is important. Like you said, only 1-2% of it is analyzed, right? But you can't miss it, because otherwise you miss something that the data is trying to tell you. So first, let's agree that it is all about the data.
Totally.
Next, let's agree that the data can come from IoT sensors and things, and it can also come from traditional business sources, and it can come from social media feeds and text messages, photographs, and everything else in between. So first step, you got to know how to access it and collect it. You mean accessing it means you're going to get it from somewhere. You're going to collect it and make sense of it somewhere. Once you do that, then you begin to understand where the data is, what form it's in, and you can create like a catalog. Back in the old days, you had a catalog that Sears used to sell. You open that up and it's got all kinds of products organized by alphabetical order or by price, and you can go through it and understand what's available for the store. Well, often if you work for a large company, you do not even know what data your company has that you can or cannot use. If you're a retailer selling a brand of sneakers through Amazon, and you are the designer that wants to understand what your next color should be and who should you target it to, a male audience or a female audience. In order for you to collect that demographic saying, I want to target this for the Western coast of the United States, and I want to know whether it should be blue or pink, and I want to know, are there more males or females that buy this, or kids who buy my products? How do you begin to understand what data is available for you to start doing that analysis internally? You have to go through all the sellers, all the outlets that you have. You got to go through the Amazon types and understand all your data, and then try to get an understanding of what you have and then what else you might need. But first, get a today's eye view on what you have available. So that's the catalog. That's your data catalog. It'll tell you what your data sources are, where are they, what's available to you. What's available to you is important because not everything is available to you or should be available to you either.
Now, is it fair to say that, like, when I thought about data in the past, and again, working in oil and gas and thinking about, we're collecting production data, we have seismic data, we have drilling data, we have all this data, and that generally I knew they were in disparate systems, legacy systems, new systems. Each engineer had their own spreadsheet, so there were multiple copies of the same system. And when I thought about data, that's sort of where I stopped, to be honest. It was sort of like, where is the data? How do I put it into the thing that I need? And then once I figured that out, I never really thought about it again. And again, one of the reasons I really wanted to have this conversation live and for the podcast was because, like, this is where my knowledge base stopped. And there was like 17 more arrows and a whole bunch of other things that happened, which is fascinating because I never thought about IT, even just the complexity of what IT is trying to do in an organization. I never thought about it as deeply. So please carry on.
Right. So let's say you are the shoe designer and you go to your IT sourcer of data and you say, hey, I want this kind of data, right? He can help you create this catalog, or she can help you create this catalog. But more importantly, he also or she understands what data do you have access to or should you have access to. So if you get all this data from your third-party seller and understand where your shoes have been sold and who's been buying it, well, from that source database, you may have columns in there, which includes a user's credit card number or personal street address or a social security number or whatever else, right?
The so-called PPI.
But PII, personally identifiable
PII.
information,
PII,
or even information which is not personally identifiable, but you have no business knowing it, right? If that is the case, then those columns of data or those branches of data have to be obfuscated, and you do not need it. Maybe you don't even need it. Why should you even get it? It may just be a headache for you, right? So understanding what data is available, what should I get, cataloging it correctly, and then once you've created this, it needs to be repeatable. It needs to be something that you remember yourself for next time use. Like you said, you were done once and then you kind of forgot about it. But if you had to do it again, you'd have to start the entire process again. But what if you properly stored it, organized it, and added your own tags to remember it by, right? Now you add your personal tags to it. And it's much like saving an Excel file with a version where you said, data extracted on this date, gotten to me by X person and stored for this use or for this customer. And you can add your intelligence to it. It's meta tagging, it's metadata. So like the example we were talking about on a cassette, I also grew up in the era of the cassettes in the 80s, right? You had to rewind and forward everything. And all you got was a one-liner little thing with some liner notes and the tracks and the names of the tracks. And that was kind of it. And when we finally learned how to digitize it and put it on a CD, we had an MP3 file or maybe an MP4 file with some kind of a name on it. You rip the CD and that's all you get back onto your computer, right? Compare that with the same song now available on the iTunes store, right? You have the song, you have the lyrics to the song, you know who was the publishers for the song, what was the album art cover, what went in the making of the song and where it was recorded. That data is sliced so many more times and is linked to videos and performances. And there's a video section at the bottom too. It gets so much more richer. It's so much more user-friendly. And it doesn't even have to be stored anymore on your device because it's in the cloud and you can play it whenever you want because the fees to get the data and pay for the cloud is nothing. It's $15 for a family of 4, any song accessible anywhere in the world with all this rich content that goes along with it and not just song name.mp3.
Isn't that mind-boggling? Like I think about the disruption to the music industry as a result of this, and the fact that I can play any song anywhere, anytime from any album, know the lyrics, and like see live performances, and I just expect it. I pick up my phone and you could tell me anything, and I can solve it. And you think about the computer processing power of this versus like a rocket ship in 1969 that landed on the moon. And I bet that this is more powerful than the rocket ship.
No, this is. The Apple Watch has got more processing power than the first few satellites we spent or what we sent to the moon first time in 1968.
Is that outrageous? This is insane. It's mind-boggling to me. Is there a limit? Like I know they talk about processing speed, and I think it's Moore's law says every 18 months the processing speed doubles. We have to be near the technological limit, because I also think a lot of people apply Moore's law in processing to like, well, we'll solve the battery issue. Technology will solve a lot of issues. They seem different. Are we ever going to reach the end of processing power?
No, we're not. And I say this with confidence. I used to be a chip designer after I got my master's degree, and I worked on semiconductor chip designs. And the smallest node I worked on was 135 nanometer. Which means that the smallest transistor size you could have was 135 nanometer process. That was what determined the scale of the semiconductor process. We are now beyond smaller than 7 nanometers.
7.
Now, so we're micrometers to nanometers. Right. I'm not going to do the math on my head, but it's probably in the order of 1 million X or 10,000x smaller, right? Don't quote me on the numbers. But to go
really
from
small.
135 micrometers to 7 nanometers, and knowing that the leading semiconductor companies, where I have very good friends and ex-colleagues who we communicate with on a very close basis, and where they're telling me in the next generation processes are going, it is a completely different scale. It is Moore's law accelerated and slowed down in some cases, rightly so, because the return on value for getting that much more performance or that much lower power is really not worth the expense of doing it. So it's also gotten a lot more expensive. So the business is beginning to rule and dictate whether you should follow Moore's law or not. You don't always have to. But in many cases, like in the large chip business, where you're doing a lot of heavy duty computing, like the Intel, AMDs, and NVIDIAs, it is absolutely a must. And they're stacking transistors in 3 dimensions and not just one layer anymore. They're stacked. There are multiple chips inside, and you're combining functionality, lowering the power requirements, shutting off power where you don't need it, and doing a lot more in a tiny space. This entire watch is one chip. So it's got Wi-Fi and cellular and processing and everything that you can think of.
Now we talk about microchips, and I wanted, because I recently had to get my car repaired, and I overheard the salesman say that the car shortage, so the reason used car market has been so strong and the new car market is so slow is not because of materials, it's not even supply chain, it's microchip manufacturing, which I assume is somewhat related to your point that in the last 2 years 90% of the data has been created, which means something is creating it, and it's got to be all these microchips and microcomputers that are building, gathering, and annotating. Is that a problem? The fact that we're moving so far down this, everything has to have a processor and can microchip everything, but now we can't even build them, so we can't build cars, we can't build houses, we can't build fridges. What's the trade-off there?
I don't think there's a trade-off besides being able to create a new rule that is better than supply and demand. And I don't see that happening anytime soon. As long as there is a strong demand for it, there will be a supply for it. And if the demand is strong and the supply is short, you're going to have a problem like we are having right now in the automobile industry, where there is just too much demand for semiconductor products, and the semiconductor companies cannot make them fast enough. I have friends telling me that they have a waiting list of 18 months for their customers. And even if they put in that, they have to put a down payment and create a booking. And the booking is not cancelable. And the orders are NCNR, non-cancelable, non-returnable. That means you are telling them that I need 10,000 chips a year from now. And if you decide not to take them, you are beholden to us in a court of law to buy them from us. And even with that, they're not able to get customers to cool off on their orders. People have been talking about how the semiconductor industry has been plateauing for the past 25 years since I joined, and it hasn't happened yet.
That is incredible. Okay, so that was and now for listeners, now you know Shamik was my favorite person to talk to over the last month. Now, of course, if I talk to you, I don't want you to take offense to that. I'm just saying he is one of the greatest teachers, and being able to take a lot of the things that we see every day and don't really think about more deeply. I found it fascinating. So please carry on with the next arrow.
Absolutely. So once you've gotten your data, you understood it, and you cataloged it, and you enriched it by adding your own metadata to it. Now you can begin to organize it in the scheme that you want it to be. So you may have data that's organized by customer name, last name, then your state that they live in, and then their gender, and then their color preferences or whatever that is. And you may decide, I only need to know whether the customer is male or female, and whether it's in the state of California or Washington, and nothing else. So your business model for how you want the data organized is different from the business model of what the original data was. So that has to be transformed. So what you've done is you took data from one data storage unit, one database, you extracted it, right? Then you transformed it to match your format and your business needs, or your logical data model, or what we call a schema, SCHEMA. And then you're going to load it into a different database. On your end, I took the data from where it may have resided in Amazon's world or somewhere else, and I brought it in, I extracted it from there, I transformed it to what I needed it to look like or what's important to me, or I enriched it with my own data or merged it with other third-party data. that I had in my stores, and then I'm going to store it somewhere else. So I've extracted, transformed, and load. That process is called ETL. And there are businesses made out of, entire industry has come out of ETL 30 years ago, where they extracted data, transformed it, and loaded it. Sometimes there's a small variation of it called extract, load, and transform, where you extract it from one place, you load it into a data lake or a data warehouse, a technology term for storing all the data in a nice flat way, and then you load it into some another database or some other store, or you transform it after you have loaded it. So instead of ETL, you have ELT. Idea is the same. You're going to take data from one place, you're going to transform it to something you can use, and you're going to store it in a third place, right? Now you've done that, you've identified it, you've organized it, you have stored it in another database. Where you store it is important. You may decide to store it in a very high, low latency, which means a very fast reacting but expensive storage type like flash, or if it's not that important for you to get it very, very quickly all the time, and it doesn't have to be very high performing, you can store it in a cheaper storage unit. So something that is not flash based, but maybe hard disk drive based, maybe even tape drive based, because you want to store it for a long time and not access it all the time, right? You can always get it. The time it takes to get it varies depending on how high performance it is. Once you've done all that, you can now start integrating it and blending it and start modeling the data. Now you can look inside and create an algorithm, like a machine learning algorithm, to say, what does this contain? What data, what is inside this data that I can find a trend from? Let's say I'm an electric utility. I live in California. My local utility has been serving the state, 80% of the state, for the past 70 years. Think about how much customer data they have. My own house here, they have data on this house that goes back 55 years through 4 different owners. They know what the meter data is, what the energy usage data is, what my neighbors are using around me, what the transformer is at the end of the street, what it can and cannot service, what the energy patterns have been in this state, in this house over the past 70 years, and I'm just one guy. And they've been doing it for 30 million customers over 70 years. Think about all the data that they have. Now imagine, is there anything in that data that can be useful to them? Absolutely. Let's say they say, how many people in this block of Cupertino is likely to buy an electric car in the next 5 years? Can the data tell them that? Absolutely. Can they do it? They're not data scientists. They're a utility, right? Should they even bother? No, and they're not going to. What they can do is they can hire a data scientist or another firm, maybe even someone like us, to come and look at the data and find them a trend from it. But before that third-party company can do and find any trend analysis on it, run some kind of a data science model or a machine learning model on it, they have to do everything, all 4 of these arrows. The black, gray, the orange, and the green arrow has to be followed through. That takes 80% of the time. Getting the data ready into a format, into a database, into a storage unit, into the schema that you need before I can use it is 80% of the effort. And data ops, data operations, everything, all the other buzzwords that you heard about, everybody is trying to make that cycle as short and easy as possible. Once you've done all that, you just have to visualize the data and create it and present it in forms that people are used to, like a dashboard or like a nice visual, or maybe an Excel file or a text alert. And it has to be on demand. It has to be adjustable. I should be able to dynamically change what kind of report I'm looking at. If I'm looking at it on a mobile phone, the format should change. If I'm looking at it at a PC, I might get more information about what data I'm looking at. And I should be able to take that same report, the results of my analysis, and be able to send it to other tools that people are already comfortable with. I can't force them to use my own visualization tools because there are lots of visualization tools available in the world. There's Microsoft Power BI, there is Tableau, there is C tools. There are many other tools that people are already using. So why can't I give them the data so they can just open it up in their own favorite program and look at it in any visual way that they're familiar with?
So to go back just 1 second before I let you continue, I wanted to, my mind's been racking. So how could you use 70 years of data on consumers to determine who would want to buy an electric vehicle? It was such an interesting comment. I wanted to go back to that just for a second. What does that even look like? I mean, I'm sure, you tell me, what does that look like?
So they know who the customer is. They know where they live. They have analysis, or they have data on who around them has bought an electric car. They know probably where you work. They know your credit history. They know your billing information. They can blend it and analyze your social media feeds and look at your public Twitter or Facebook posts or whatever. Try to find out whether, I don't know, whether you're a registered Democrat or Republican, whoever. And they can do an analysis on all of these data sets to try and arrive at a picture for what this customer is going to perhaps buy in the future. Are they likely to buy an electric car because 5 of the neighbors did? Are their social leanings such that they are heavily pro-renewables? Are they the kind who are on an expensive tariff right now, such that when they buy an electric car, their bills are going to shoot to the roof unless they change their tariffs to a time of use pay, where you get paid, where the charges of electricity are lower after 11 p.m. and before 6 a.m., often when electricity is at its cheapest price. So they can, understanding all of this, gets them an ability to have one of their partners come and approach you with an electric charger for your house, right? Or target an ad to you, or try to sell you solar panels or an energy storage system for your house.
I mean, for listeners, I hope your mind was blown just as much as mine, because again, we all know this, or at least maybe we don't know it because it's too scary to actually fully integrate. But the fact that you just told me, because of course, if I'm just, I'm a number, I still find it funny that a credit card number is 16 digits and a social security number is like 10 digits. So it's like a phone number. And we basically, like, this is how we differentiate ourselves from the rest of the world. But to your point, they could do everything on me. They could look at trends. They could use machine learning and AI to figure out, like, if this was my trend in energy, then my neighbor did this, and therefore, like, consumer patterns are so predictable if you can look at all the data and just machinate, and boom, there's your answer. I mean, it's truly incredible. It almost makes you wonder about free thought versus not. Because on the one hand, your neighbors are all buying the car and then it's planting. And then on the other hand, someone comes to your door to sell you solar panels and upgrade your electrical system. And the next thing you know, you too are driving an electric vehicle. It's really interesting to think about.
It is. And I'm a firm believer, because I've worked with energy utilities for 10 years almost. They are doing this for all the right reasons. They're not just doing this because they want to steal your data. They don't want to sell you products that you don't need. They're trying to understand what you may find of value. Do you get a lot of junk mail from your utility, or emails or text messages asking you if you're interested in solar panels? I don't.
I don't.
I don't get them at all.
No.
I don't. When I log into my account, it tells me whether I could be eligible for solar. And if I'm interested, I have to fill out a form and have one of their partners contact me. But I don't get a lot of ads shoved in my face. And partly it's because they have not done that analysis. Some of it is done, and some states are ahead of others. And also because they are a public utility and they are bound by privacy laws. They are there cannot just take our information and sell it to any of their partners and have them go willy-nilly with their ads at us either. So I do believe that they're doing this for the right reasons. They need to understand what portions of the grid they'll have to update with the right transformer setting. Because if there are 5 cars on my street and all of them are going to suck in 7 kilowatts at 11 p.m. every single night, and their local transformer is only rated for 60 kilowatts, all of a sudden I'm going to exceed my maximum capacities. They have to update the transformer. But the earlier they know that, the better off we all are. You don't want everybody else to get a brownout, least of all me.
So it's also fascinating, and then we'll go to the next slide. But again, and this is all happening in real time, so I'm thinking this out loud. But it's crazy to me to think about Google as an example. In Google, through Gmail, they have every single person who has a Gmail account. They have everything they've ever written to everyone. Your computer, through Google primarily, which is 92% of the search in the world, stores your search history. And I'm sure even if you turn your browser history off or whatever, Google knows, they know the IP, they know the address. It's linked because everything now links. They said, do you want to log into this via your Gmail account, which almost is like the standard. So they have the perfect data set of every single thing you are. They know who you are, who you see, where you go, how you drive, what you spend on. I mean, that is the perfect data to, and I don't mean to make it sound bad, but like you could weaponize that, because you could literally present to the person at the exact moment they're going to spend the exact thing that you know they're going to buy, and charge someone else for the right to do that.
Right. And my friends and I ran a completely innocent experiment once. We were all into bicycling. So, we were having this discussion whether there are any AI programs at Google or wherever, Yahoo Mail, whoever, whether they're reading your emails, right? And we bet that nobody is reading the emails. Even if they have algorithms that can read the emails, they're not going to do it. And for 10 years, we've been emailing each other back and forth with all kinds of high-end bicycle accessories, bicycle names, part names, logos, and everything else back and forth to try and get someone from any of those companies to offer us something at a high discount. We're testing it out to see, all right, marketing people, have at it. I'm in the market for blah, 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 and blah, and I list out 5 things and I change it every few months, and we email each other in a group of 4 back and forth. We've been doing it for 10 years. I've yet to get a single email offer of a very good deal come to me. Well, that's not the same as tracking. Yeah.
That makes me feel good.
It hasn't happened.
If it changes, I want you to make sure you let me know first. But that is encouraging. That is encouraging.
They don't do that. They want to stay in business. They want your business. They don't want you to be afraid of you.
It's truly mind blowing. Okay, so carry on.
Right. So once you've done all of that, we at Hitachi Vantara, we back all of this up with services and support and training end to end, as the bottom arrow shows. And what we then do is tell you what's available in terms of the different products. So this is not a big corporate plug here. I do not want to appear that kind of a marketing person. But we have tools called Lumada Data Integration and Lumada Edge Intelligence. One is a data catalog, as I explained, to understand what's happening at the edge or not. And those acronyms and where they play are listed out over here. And then my second slide is to just give you like a architecture of what that means, right? Whether you are processing data at the edge or taking it to the cloud or multiple clouds, you're doing this data management function. And what does that really look like? And what does that mean? And so this chart again goes from left to right as well. You on the left, you are the sources. Then you can go on to what's happening at the edge. Then you process the data, and then you move on. But on the left, you have your IT sources and your OT sources. OT is operational technology.
Yeah, could you explain the difference on those terms? That was something that was new to me, was the difference between the IT source and the OT source.
Right. So IT source is where, going back to our utility example, they may be storing customer data and my credit card information and everything in their Oracle database or a SAP implementation or something like that. What we call ERP, Enterprise Resource Planning, right? That's where all your business data resides. And it's usually all text data or some photographs and others, but it's usually text-based data. Your IT or your OT sources, operational technology sources, are your IoT, and that's where your things are sending. That could be from a process like a robot, or it could be from a thermometer. It could be from an agricultural moisture sensor that's detecting how much moisture is in the roots and telling your sprinkler system to turn on or off. It could be an anemometer, which measures the wind speed on a wind turbine to detect when wind patterns are getting too fast and you may need to shut down the turbine. Or a buoy on the ocean that measures wave height based upon how much it's bouncing and how frequently, to alert a boat crew not to come out because of hazardous conditions, right? So those are the things that are sending these data over. All of that inside the IoT platform that we call Lumada is then processed at the edge and determined whether it needs to be understood and analyzed right at the edge or sent over to the cloud or other deeper portions of the software. Now, an idea of edge you have a question, or should I go on?
That was exactly what I was going to ask. I wanted you to explain the difference between the edge and the cloud.
So the edge would be what happens, let's say, in a car, where you have a self-driving car approaching an intersection, and it needs to make a quick determination whether that 3-foot tall object that's rolling towards a curb, towards the road, is that a runaway suitcase or is that a child in a stroller? And it needs to make that determination and understand how suddenly it has to brake and how quickly to avoid that, based upon whether it is a shopping cart or a piece of luggage versus a human being or a small human being. You cannot wait for that data to be sent to the cloud and then have some intelligence run on it and have a command given back to the car saying brake right away, or just slow down, it's likely to stop based upon its trajectory, right? That intelligence has to be understood in the car. So modern day cars, which are self-driving, are going to have a lot of edge intelligence built into it.
Okay, that's a great description.
On the other hand, when your IT data, where you have your ERP data, your customer data, that doesn't need to be analyzed at the edge. That's usually blended and kept in the cloud anyways. So that arrow going from your IT sources goes straight into that data scope, where you either store it in a S3, Amazon, or you have it in a Hadoop distributed file system, or some kind of a SQL or no SQL database. You integrate that data. So now you've taken your edge data from your IoT sources, your IoT data from your machines and things, and you integrate that with IT data, relevant data, and then you create a catalog of all the data, where it's coming from. You can put it all into a nice flat architecture called a data lake. Literally, as the name suggests, it's a lake of data. And then you run some analytical services on top of it, like we discussed. You start running some applications after that to make things easier. And to make things easier, we have created specific vertical and micro vertical applications, like video insights, specially built hardware and software solution and intelligence products that understands what your video or LiDAR feeds are saying. You have somebody too close to some critical equipment. Do we know who that person is? Can I identify somebody wearing a green raincoat on platform number 9 at Paddington Station between Tuesday and Thursday of last year, April? Those kind of insights that can be run on that for security purposes, for asset performance and optimizing how well your machines work, understanding the data, understanding how it's performing next to its peers, when was it last maintained? If I don't maintain it right now, but run it at half power, can I extend its life when I do have scheduled maintenance? Is it better for it to let it fail, or should I wait for run it at half power so that I don't have to send out a new truck roll to maintain it?
So let's stop sharing the slide, because I want to see your face for this one. And it's sort of our last question, and it's a big one, and it's a bit of a, if you think to the next 5 years, to the next 10 years, the technology evolution, but then everything you just described, 90% of the data is being collected in the last 2 years, that we can identify someone who was wearing a green jacket on Paddington Station with any time within the last year. The amount of computing power and storage and data and memory and processing and networking required to do that is so immense. Where do we go in terms of like artificial intelligence, robots taking over the world, and humans just not being relevant? Like, in order for a business to perform at its highest level, when all that data is out there, you're crazy not to use it to compete, but it makes us who process slower kind of obsolete. So where do you fall in that whole balance of robots and AI and machine learning in the future of the next 5 to 10 years?
I think it'll make us smarter. Here's what I mean. Before Homo sapiens came along, Neanderthals and all our other ancestors, they all had far larger brains than we do. They had bigger skulls and bigger brains than we do. The human brain is a lot smaller now, and it's shrinking further. Head sizes are not going up, they're going down, right? And the reason that's happening is because our brains are getting so much smarter that we don't need as much area for all that information anymore. So what used to be large amounts of brain cells reserved for understanding whether this animal is somebody that will die with a spear, or I better run and leave this one alone because it's going to kill me instead. I don't need that anymore because I go to a supermarket and buy the piece of meat anymore now, right?
Right.
So the brains get smaller and they get more efficient because now look at what we are capable of compared to what our prehistoric ancestors were capable of. Similarly, we're going to start outsourcing some of our functionality of the brain to things that we would never imagine today. For example, never needing to know directions. East, west, north, or south, or never knowing where to go, what highways I have to take to go from here to New York City. I will never need to know that. I will never need to remember a name or a face again because there'll be augmented reality in my reading glasses or in my contact lenses that will automatically pull up the name of the person and how I know that person in my field of vision. And I will never need to remember who I have met in my life because AR will take care of it. I think the brain will get smaller, but a lot more efficient. It will remember, for example, where I had stored that information and whether I need to upgrade my prime settings so that I don't lose it all. And it may just remind me to send a note to my cellular supplier to do not subscribe me to a certain service. And I'll have that portions of my psyche get far smarter. But I do not think robots are going to take over. I do think that this is all going to work in conjunction with us human beings. We'll continue to remain completely in control of whatever we need to do. Eternal optimist, eternal technologist. I believe all technology is here to help mankind, not to ruin us.
I absolutely love that closing, and I think we don't usually cut out like clips of things and be like, this is the one clip, but that, I mean, it is fascinating to think about shrinking and efficiency and energy use, and you're right. I mean, I remember being in Italy 20 years ago and pulling the car over with 3 friends, putting the map on the hood, having no idea where we were going, and fighting about how we were going to get there. And now it just doesn't dawn. My kids don't have it. They couldn't get to their friend's house if they didn't have it in their map.
Exactly.
So I want to ask you a personal question, which is, if you could give yourself advice to 20 years ago, you get transported through time and you get to give yourself advice that would impact your life or impact your career, what advice would you give yourself?
A good question. A very good question. I would say get broader. I would have wanted to have more experiences from a broader range than I do. I worked only in technology companies, whether it's semiconductors or renewable energy technologies or software and data management. But I do not know enough about, let's say, the healthcare industry. I do not know enough about the sustainability. I would have liked to have the broader exposure to many more things. I think I changed my industry 3 times in, 27 years. I would wish I had changed it more like 5 times. So a little bit of that, having faith and patience that things always do work out. I have been impatient in the past and I've been a little, quick to, jump the gun, as I say. But I would say, get broader, get exposure to far smarter people than yourself. All the time, strive for that, and have the patience to calmly process things and take your time.
I love that advice, and I love your construct that good things ultimately happen to good people, which closes us with our boy John Rahm, who, leading the tournament 2 weeks ago by 6 strokes, was informed as he walked off the 18th green that he had failed the COVID protocol in spite of 4 negative tests and not showing any symptoms, and he was forced to withdraw from a tournament he absolutely 100% could have won and would have won. And instead of him getting mad, instead of him getting frustrated, instead of him having a tantrum, he redoubled his positivity. And this weekend, fist pumped after a birdie on the 18th hole to win the US Open. So good things come to good people as long as you just wait. I too have more faith in humanity, especially after this conversation. And Shamik, I really appreciate you joining. I know we had some of this conversation last week, and I had to share it with everyone because I think it's fascinating. Hopefully the listeners have learned more about IT, how your data is being collected, being used, being aggregated, and you're going to go give your IT guy a big high five the next time you see him, because it's a way more complicated than I thought. So Shamik, thank you so much for joining us.
Thank you, David. My pleasure. Thanks for having me.
Until next time, be safe, be good, have a great day, and bye for now.